Hello everyone, in this video we are going to be looking at applications of trigonometry or word problems with trigonometry. If you haven't seen my videos on Pythagorean theorem and trigonometry, I highly suggest you go see those first and then come back to look at the word problems. So just as a quick review, with trigonometry and Pythagorean theorem, you can pretty much solve for all of the angles and side lengths of a right angle triangle if you're given two pieces of information. So what we're going to do is just practice that first, and then we'll jump into the word problem. So for example, solve for all the missing pieces of a right triangle where A equals 5.7 and C equals 7.2. So here is our triangle here. When we're looking at labeling it as ABC, the capital letters are used for the angle. So this is angle A, angle B, angle C, which is 90 degrees always. And then the side lengths use lowercase, and they're always across from their angle. So if this is angle A, then this is side A. If this is angle B, this is side B. Angle C is side C, and so on. So let's solve for all the missing pieces. Right now, we know that this is 7.2 and this is 5.7. And we want to find side B, angle B, and angle A. That's what's missing. So the first thing we can do is find B using the Pythagorean theorem because we know two sides of a triangle. Pythagorean theorem is c squared equals a squared plus b squared. So I'm going to put in the information that I know. I need to do a little bit of rearranging here because I'm looking for B. And then I can square my numbers and subtract them. And then to get B by itself, we have to square root it in order to find B, not B squared. And we get 4.39, so on and so on. I'm going to round that to 4.4. So now we know our third side. We can find our other two using trigonometry. So to find angle A, we can use side A and side C. Now I know we just found side B, but I always like to go back to what we're given in the question in case I made a computation error here. I'm not carrying that through in my next step. So if you can, use the information you are given. So if I'm looking for side A and I'm using side A and C, that tells me that this is the hypotenuse. This is opposite because it's opposite A. This will be adjacent. And so I'm thinking about which trigonomic ratio uses opposite and hypotenuse, and that is the sine function. So sine of A is 5.7 over 7.2. I'm going to do the inverse sine in order to get my angle. And I get 52.34153 and so on. I'm going to round that to 52 degrees. Lastly, we want to find angle B. And to find that, again, I'm going to use side A and C because that's what was given. So based on angle B, this is my hypotenuse. This side, side B, is now opposite because it's opposite our angle we're looking for. And this will be my adjacent. So I'm looking for which trigonometric ratio uses adjacent and hypotenuse, and that is the cosine. And I'm going to do the inverse to find an angle, and I get 38 degrees. Now, the other way we could have done this is how we're going to check our answer, and that is to make sure that all our angles add up to 180 degrees, which they do. So you could have just done 180 minus 90 minus 52 to find that answer, but I wanted to use trigonometry and then use my 180 degree add up to check my work. So let's go forward into our word problems with right triangles. Now, a couple of definitions that help us with these types of questions. We have the angle of elevation, which is the upward angle from a horizontal line up to an object we're looking for. So if this is where my eye is, I'm going from a horizontal line up to where I'm looking at an object. That angle there is my angle of elevation. The angle of depression is from the horizontal level of my eye down to an object. A common error here is to do this angle as the angle of depression, but it's this angle here. The key thing to remember is both the angle of depression and the angle of elevation start from a horizontal line and go up or down. Okay, so it doesn't start from an angle to a vertical line. It starts from the horizontal line down to the line of sight to the object. So keeping that in mind, let's look at some word problems. A 10-foot ladder leans against a vertical wall. The base of the ladder is 6 feet from the wall. What angle does the ladder make with the ground? And this would be the angle of elevation. Wants to round your answer to the nearest hundredth. So with word problems, I know this is a right triangle that I'm working with. So I'm going to start just by drawing a basic right angle triangle. It does not have to be to scale. It's just to give us an idea of what we're looking at. So I draw a right angle triangle and I'm going to label what I know. A 10-foot ladder leans against a vertical wall. So this side is my 10-foot ladder, and it's leaning against a wall. The base of the ladder, or the bottom of the ladder, is 6 feet from the wall. So I'm going to label that as 6 feet. What angle does the ladder make with the ground? So that'd be this angle here is our angle of elevation. It goes from the horizontal of the ground up to the ladder. And I'm looking at rounding this to the nearest hundredth. So here's the information that I know, and now I can solve the problem just like I did in our review question. So I'm going to label my sides. I have the hypotenuse, which is always the easiest to label. This is going to be my opposite because it's opposite my angle, and this is my adjacent. So I'm looking at which trigonometric ratio uses adjacent and hypotenuse, and that is the cosine law. So I'm going to do cosine of our angle equals 6 over 10 adjacent over hypotenuse. To find our angle, I'm going to find the inverse, and I get 53.13. So the angle of elevation of the ladder is 53.13 degrees. So the hardest part of these is just drawing the picture and pulling out the information that you need. A person stands 50 feet from the base of a tree. The angle of elevation from the ground to the top of the tree is 30 degrees. How tall is the tree? And it wants us to round our answer to the nearest tenth. And I'm just going to draw a basic right angle triangle and fill in the information. So a person is standing 50 feet from the base of a tree. The angle of elevation from the ground up to the tree is 30 degrees. So that's our angle of elevation there. And it wants to know how tall is our tree. So let's label our sides. We have our hypotenuse. Based off the 30-degree angle, this side is going to be our opposite, and this is our adjacent. So I'm working with opposite and adjacent sides, which is the tan function. So tan of 30 equals x over 50. We can cross multiply. If we picture that there's a 1 under here, I get x times 1, 50 times tan 30. So I get x equals 50 times tan 30, which is 28.9 feet when rounded to the nearest tenth. Okay, a 30-foot building casts a 20-foot shadow at 1 p.m. What is the sun's angle of elevation? Round your answer to the nearest tenth. If you're feeling comfortable, I would like you to pause the video and try this out, and then start it up again when you're ready. I'm going to start with just drawing a right angle triangle. I know the building is 30 feet, and it's a 20-foot shadow, and it wants to know what this angle of elevation is. I'm going to label my sides. I get hypotenuse, opposite, adjacent, which is my tan function. To get the angle, I'm going to do the inverse tan, and I get 56.3 degrees. Let's look at some angle of depression questions. An airplane is flying in an altitude of 5,000 feet. The angle of depression from the airplane to the point on the ground is 40 degrees. How far is the airplane horizontally from this point? And it wants us to round your answer to the nearest whole foot. So let's try and draw this out. Again, we'll start with just a basic triangle. And here is my airplane. It's flying at 5,000 feet. The angle of depression from the airplane to the point of the ground is 40 degrees. And a lot of us want to put this angle here as 40 degrees. However, remember, the angle of depression has to start at a horizontal line. So this is actually 40 degrees. and it wants to know how far the plane is horizontally to this point on the ground. So before I can try and figure this out, I need to make sure that I have enough information. In order to solve with trigonometry, I need two pieces of information about the triangle, and right now I only have one. But I can use this angle of depression in order to tell me what this angle is, which will give me enough information to find x. So I really need to find theta first, and then I can use trigonometry to find x. And if we remember back to complementary angles are angles that add up to be 90 degrees. And so I can do 90 minus 40 to tell me that theta is 50. And now that I know that angle, based off that angle, I'm going to solve my trigonometry question. So based off that angle, this is my hypotenuse, this is my opposite, and this is my adjacent. So I'm going to be using opposite and adjacent, which is my tan function. So tan of 50 equals x over 5,000. When I cross multiply, I get x equals 5,000 times tan 50, which gives me 5,959 feet when rounded to the nearest whole foot. Okay, so be very careful with your angle of depression, and it's not this angle. Your angle of depression has to start from a horizontal line down to the angle of your eyesight here to this point. So from here to here. We need to do a little bit of an extra step in order to figure out the angle we can use with our trigonometry. Let's look at another one. A zip line is installed between two platforms. The starting platform is 80 feet high and the ending platform is 20 feet high. The horizontal distance between the two platforms is 200 feet. At what angle does the zip line descend the angle of depression? And we're going to round our answer to the nearest tenth. So then let's break this down. Let's just start with our normal triangle and fill in the information. The starting platform is 80 feet high. So I have kind of platforms that come up here. They don't start at 0. So I'm going to extend some lines from our triangle. If this was 0 feet high, then this could be 80, but that's not the case, right? This whole thing is 80, and this point that they end at is 20 feet high. The horizontal distance between them is 200. Okay, so we have a platform up here, 80 feet high, a platform here, 20 feet high, and 200 feet between them. And it wants to know, at what angle does the zip line descend? And again, that's not this angle, that's this angle it wants us to figure out. So we have a couple things we need to do first before we can jump into using trigonometry. First of all, I only really know one piece of information about this triangle. I know this bottom is 200 feet, but I don't know this distance, and I don't know this distance here. Right? So I'm going to need to find a couple things out about this triangle. I'm going to need to find this distance here and this angle here in order to find this. So I'm going to find this angle in order to find this, and in order to find this angle, I need two pieces of information about this triangle. The best piece of information I can find is this distance here, because I know this whole distance and I know this whole distance. I don't really know anything about this, so there's not really a way for me to figure this information out. So to start off, this distance is going to be our 80 minus 20. How far did they actually descend on the zip line? They descended 60 feet. So we know this is 60. We know this is 200. So now I can figure out this angle here using trigonometry. I'm going to label my sides. I have hypotenuse, opposite and adjacent. I'm going to be using opposite and adjacent, which is our tan function. So it's tan of alpha is going to be 200 over x, which is 60. I'm going to do the inverse tan to get 200 over 60. So this angle here is 73.3007, so on and so on. I'm not rounding my answer yet because I'm not done. To figure out my angle of depression, I'm going to do 90 minus that number, and then I can round to the nearest tenth and get 16.7. So a bit of a tricky question because we're not given all the information we need to figure out that angle of depression. We have to kind of find some bits of information first before we can get there. So So I want you to think about how you've done with solving word problems that have to do with right triangles and trigonometry. If you are a sad face, that means that you're very confused, and so I suggest you go back to the trigonometry video. Make sure you're really solid on your trigonometry before trying to jump into the word problems. If you're a thoughtful face, it means you need more practice. So you're going to look at the practice problems assigned by your teacher. And if you're a happy face, it means you got this. You were able to get all the way through to the last question and you know exactly what to do. I still suggest practicing a few questions to make sure it's stuck in your brain, and then you're good to go on to the next topic.